Okay, so let's do mesh number 2. So this is for mesh I2. Let's start at the top again. So we have 8 times I2, remember V equals IR. So 8I2, and now the current is going into the positive terminal of the 400 volt source. So we have plus 400. That's already in volts, so we don't have to multiply by the current like we do for the ohms, for the resistances. And then we have 2 times I2, which is going in the same direction as I3 equals 12 amps. So we have I2 plus 12. They're working together there. And then we have plus 40. That's a plus 40 times I2 now is the positive one, and I1 is working against it. So we have I2 minus I1. And we already did 8. Okay, so all of that sums to 0 volts. Beautiful. So let's do the same thing as we did on the first mesh. Gather all our terms. So we have 8I2 here, and another 2 is 10, and another 40 is 50I2. 50I2. And then let's gather our I1s. Well, there's only one. 40 times negative I1 is at negative 40I1. Negative 40I1 plus 50I2. And then all of our plain old numbers. We have 400, and 2 times 12 is 24. So we have plus 24. Or 424, sorry. 424. That equals 0. Okay. So now I'm going to subtract 424 from both sides, and then divide everything by 10. Sorry, got a little bit of I don't know, allergies or a cold or something. So divide everything by 10, and we have negative 4I1 plus 5I2 is equal to, now this becomes negative 42.4 after we subtract it over, or excuse me, negative 424 after we subtract it over. Then we divide by 10, and we're left with negative 42.4. Okay, so this is our second equation. So we have our equation from before, and this one, okay, so I'm going to write both of these, yeah, I'll write them both up here, and then we're going to solve them. Okay, so at this point, here are our two equations. 8I1 minus 5I2 equals 54. And negative 4I1 plus 5I2 equals negative 42.4. So there are lots of ways you can solve systems of equations. You could graph these in Desmos, make I1 equal X and I2 equal Y, graph them both, find the intersection. That's one way to solve them. You can use a reduced row echelon form calculator on your TI or somewhere else. Or you can do what we're going to do, which is manipulate the linear equations and add them together. They're linear, so we can, if we add the two linear equations together, they give us a new solution, and it's still valid. So we can notice that we luckily have these opposite coefficients for I2 in both of our equations. So let's just add these directly, and we end up with 4I1 plus 0I2 is equal to 54 minus 42.4, which is 11.6. So this is 0, of course. Then we just divide both sides by 4, and we get that I1 equals 2.9 amps. Wonderful. Beautiful, mate. Awesome. So we got I1, and now let's just plug that bad boy back into our top equation here and solve for I2. So we have 8 times I1, which is 2.9, minus 5I2 equals 54. Beautiful. Now, 8 times 2.9 is 23.2, I believe. Let me check my math on that. Yes, 23.2 minus 5i2 equals 54. And then if we subtract 23.2 from a 54, then we're left with negative 5 is equal to 30.8. Sorry, negative 5 I2 is equal to 30.8. You still see that okay? All right, let's move this up here. Now, if we divide both sides by 5, then we get I2 is equal to negative 6.16 amperes. Rock on. Okay. So we got our mesh currents. Now we're asked to find the current that goes from top to bottom through the 40 ohm resistor. Well, that's awesome because we have one current that goes down through the 40 ohm and another that goes up, and we know their values. So since I1 is in the direction that we've defined, we'll take a positive I1. So we'll call this I40, and I40 is equal to positive I1 because it's going in the same direction as is asked for, minus I2, or plus negative I2, which is the same thing as minus I2, because it's going in the opposite direction. So let's plug in our values. We have I40 equals I1, which is 2.9, minus, now we have a negative 6.16. This is really messy looking, okay. And if you add those together, what do we get? We get 9.06 amps. 9.06 amps. And that is the answer. So I40, the current that is going down through the resistor is this pretty large number, 9 amps. Now, just a gut check, I think this makes sense, because if we just look at the circuit qualitatively, we have a voltage increase on both sides of this. It's almost like there's a pump of water that's just that's on either side of this middle channel, pushing current up through here. And so we're going to have a fairly large current, in fact, larger than either of these, because they're adding up to push the current through here. Very cool. All right, 9.06 amps. Good luck. Hope that made sense and it's helpful.